Yeah, then we come to the last question of this circuit, and we say bye-bye to it. Okay, it's question 1.6, and it says, with the switch S1 and S2 closed, a wire of negligible resistance is connected between A and B. So state what happens to the voltmeter reading. This question we've just answered it in the previous question, though this time around it might go in opposite direction. Like I gave you a tip. What is the tip I gave you? I told you where resistance, total resistance goes is where the voltmeter reading, terminal voltmeter reading goes. Remember, we don't talk about any other resistance here. We are talking about what? A terminal, a total resistance. So in other words, this is the setup. And in this setup, they are telling us point A is this one and point B is this one. And they are saying they are connecting a wire of negligible resistance, which is almost zero between A and B. And what happens in this case, good people? So let us follow the flow of the current. The current flows like this. It comes, it reaches this point. Now what we are going to explain is very fundamental. It's very, very important. Now the current has three alternative routes. The current can pass here. The current can pass here, or it can go this route. But there's a small problem here. Oh, let us look at this one. This route or this arm has 6 ohm, and this arm here has 7 ohm, and this one has no resistance. Now, this is how the current behaves. When it is faced with a junction where one of the alternative does not have any current, the current is very funny. It avoids all others and it passes through that channel, that connection. None will go through here. Actually, this ammeter reading will register 0 once this wire is here. None will go here. Even this one will register 0. Actually, this one, for those of you who are going to do engineering, is what we call short circuiting. These two resistors have been short circuited and they are out of the circuit. So in other words, this one is tantamounting to taking out this resistor and this arm out. So now it's like our circuit has been reshaped. Okay, if this is out and this is out, then what is there? We are having only this as our only resistor in the circuit, or only external resistor, the 5. It is the only one which is in the circuit once you perform this operation. So in other words, now we come to some explanation. They say, state what happens to the voltmeter reading. I remember what I told you. I said the tip is that where the resistance goes is where the voltmeter, terminal voltmeter reading goes. So in other words, what are you going to say? Okay, what has happened to the resistance? Oh, remember it was 8 when the spiral network was there. Now it's 5. So what has happened to the resistance? It has decreased. And so will be the terminal voltage. So what do we say? We say it decreases. Thank you. Then comes the next question, to explain your answer. Okay, then how do we explain our answer of the decrease? Okay, we'll go through the same steps and we'll start with the resistance. What happens to the resistance? You say total resistance decreases. Then what do you say? Total current increases. This one, they move in opposite directions. So what do you say? You quote the expression. You say that from E equals to VT plus IR, the factor IR increases. Because of that, remember what we said, when this increases, remember this one remains constant, this one decreases. And that's what we give as the last point. What does it say? Terminal voltage will decrease to maintain E constant. Okay, that is that. Actually, this is, I'm trying to emphasize the same idea. We did it in the question before. Then comes this question, on under this circumstance, it says, calculate the ammeter reading A. Calculating the ammeter reading A when this wire is in place. So what do we do here? You have to check which approach you are going to use. Okay, if we will have to use Ohm's law directly, we need terminal voltage. We don't have it. Total external resistance, we have it. And we are looking for ammeter reading. So in other words, Ohm's law cannot work here, but you can approach it using general equation, which says E is equal to IR, which is total, plus ITR. So this one can also come to can become our savior. So what do we know? Remember, we know EMF does not change, so it's 30 volts. We are using the same battery, and we know that R also does not change because it's the same battery. These are features of a battery. Okay, those ones are there. And if we have them, what else do we know? We know R total. What is it? 5 ohm. So when you substitute into that, we get 30, still there. I total wanted, but times R total, which is 5, plus I total times internal resistance, which is 0.75. So from here, we can proceed and compute the total current. So after computing, we get our I total in this case as 5.22 ampere. Then comes our last question of the circuit, and we close. Okay, there comes the question, the final question. It says calculate the voltmeter reading V. Now we know very well that V is V terminal, which is given by I total and R total. And we just found out that I total, in this case, when the wire is there, is 5.22 ampere. And we found out also that our R total is 5 ohms. So when you substitute in, you'll have 522 times 5, giving you, yes, giving you 26.1 volts. So this marks the end of the circuit. It was nice of you being with us, and we are going to have more questions coming. We urge you to subscribe, to like, to comment. Okay, thanks for being with us. Okay, bye.